Okay, so question is consider two sparingly soluble salts PQ and RS2 at temperature T0. Solubility products of these two salts are found to be equal. So, if you have PQ will give P plus and Q negative. Let us say solubility of PQ is S1. So it is S1, it is also S1. So KSP for PQ is equal to solubility of P plus multiplied by solubility of Q negative. That is equal to S1 square, because it is P plus raised to power 1, Q negative raised to power 1. Now RS2, that means it has R2 plus 2S negative. So solubility of R2 plus is S2. It is 2S2. So KSP of RS2, that is equal to R2 plus raised to power 1 S negative raised to power 2, means S2 into 2S2 raised to power 2. 2S2 raised to power 2. So it becomes 4S2 cube. Now it is given at T naught KSP of solubility product of PQ, that is equal to solubility product of RS2. इसका मतलब ये हुआ, we have S1 square is equal to 4S2 cube. From the first relation, from up to this, we have relation between S1 and S2. S1 square is equal to 4S2 cube. Now at a higher temperature T1 is greater than T0. Solubility of PQ becomes triple of its solubility at T0. At temperature T1 and T1 is greater than T0, solubility of PQ at T1 is equal to 3 times its solubility of PQ at T0. So at T0 it is S1. So at T1 it is 3S1, right? Because solubility of PQ becomes triple of its solubility at T0. And at another temperature T2, which is also greater than T0, solubility of RS2 becomes double of its solubility at T0. So ratio of the solubility products of PQ at T1 and RS2 at T2 is given by. Okay, that means solubility product of PQ at T1, it is solubility P plus concentration, Q negative concentration, but now it is not S1, it is 3S1. 3S1. So it becomes 9S1 square. That is the KSP of PQ at T1. Now at T2, which is also greater than T1, at this temperature, solubility of RS2 at T2 is equal to 2 times solubility of RS2 at T naught, means now Ksp of RS2 at T2, that is equal to R2 plus raised to power 1 S negative raised to power 2, and it is not S2, now it is 2S2. So 2S2 and 2 into 2S2, it is double. That means it becomes 1632 S2 Q. So now to calculate ratio, Ksp of PQ at T1 divided by Ksp of RS2 at T2, that is equal to, yes beta, it is 9S1 square divided by 32 S2 cube. Now you know S1 square is S1 square is 4S2 cube (32S2 cube). Now S2 cube is cancelled. 4 is a 32, so it becomes 9 by 8. So 9 by 8 is the answer. Great. Okay. Do this question. Equation appropriate for the exact calculation of pH of an aqueous solution of HCl at a concentration CHCl close to 10 raised to power minus 6 molar is given by. pH of an aqueous solution of HCl at a concentration, you know, if it is 10 raised to power minus 1 molar, pH is taken as 1 only. Means we neglect the contribution from water, right? But when concentration is very close to 10 raised to power minus 7, because you know in water, what is the concentration of H plus ion? 10 raised to power minus 7 molar at 25 degrees Celsius. So that's why when concentration is close to 10 raised to power minus 6 to 10 raised to power minus 8 molar, we cannot neglect the contribution from water. So contribution of water is added in it. Okay. So now, you know, H plus ion concentration, we have to calculate for the exact calculation of a pH of an aqueous solution of HCl. Now from water, you know, we have H plus ion, OH negative ion. right? Let us say H plus ion concentration, sorry, OH negative ion concentration from water, that is equal to X. So obviously OH negative ion contribution from water is also H plus ion concentration. OH negative ion contribution from water, that is also X. Now overall H plus ion concentration is concentration of H plus from the HCl, because HCl is strong electrolyte. So whole HCl gives H plus ion plus contribution of H plus from water. So this is the overall concentration of H plus ion. Means you can write it like this: H plus ion concentration total, that is equal to H plus ion concentration from HCl plus H plus ion contribution from water. That is the total H plus ion in the solution. And H plus ion from HCl is same as the concentration of HCl, and contribution from water, because it is not mentioned that it is at 25 degrees Celsius, so let us take it as X. So this is H plus ion concentration, H plus ion concentration. So that is not equal to concentration of HCl. So first option is incorrect. In case of 10 raised to power minus 1 molar HCl, exact H plus ion concentration is not equal to 10 raised per minus 1. It is 10 raised per minus 1 from HCl plus 10 raised per minus 7 from water. Kab? At 25 degrees Celsius. But this is very, very less. So it is neglected. That's why we just write H plus ion concentration is 10 raised per minus 1. So pH is equal to 1. But when concentration is very comparable, very close to 10 raised per minus 7, we cannot ignore the contribution from water. That's why it is mentioned that concentration of HCl is close to 10 raised per minus 6. So whenever concentration is in between this range, 10 raised per minus 6 to 10 raised per minus 8, we cannot neglect the contribution from water. So H plus ion concentration is concentration of HCl plus X. Now you know that what is Kw? What is Kw? It is ionic product of water. So that is equal to H plus ion concentration into OH negative ion concentration. So here, H plus ion concentration is concentration of HCl plus X into X, that is equal to Kw. Or we can write that Kw equal to H plus into X. That implies X is equal to Kw upon H plus. That means H plus ion concentration is equal to concentration of HCl plus X, and X is Kw upon H plus. So that is this one is correct. H plus ion concentration is equal to concentration of HCl plus Kw upon H plus. So B option is correct. Got it? Okay. Yes, do it. This is very easy question. I hope it is NH4Cl. 5 ml of 0.1 molar. Oh, sorry, it is not. It is HCl only, right? 0.1 normal HCl, right? 5 ml of 0.1 normal HCl. It is like this. And 10 ml of 0.1 molar H2SO4. And third is 5 ml of 0.1 normal NaOH. So what is the pH of the resulting solution? So first two are acids, third one is base. So first of all, let us calculate total volume. So volume of solution becomes 5 ml HCl, 10 ml H2SO4, 5 ml NaOH. Total 20 ml solution we have. Now, number of millimoles of H plus. See, 0.1 normal is equal to 0.1 molar. Same. So what is molarity? Number of moles upon volume of solution in liter. That means number of moles is molarity into volume in liter, and number of millimoles molarity into volume in ml. So molarity of HCl is 0.1, volume is 5, plus molarity of H2SO4, that is 0.1. But you know, H plus ion की molarity in H2SO4 is 0.2 into 10. So it becomes 0.5 plus 2, that means 2.5. Number of millimoles of H plus ion is 2.5, and number of millimoles of OH minus ion, that is equal to 0.1 into 5, so 0.5. 0.5. Why I took it as 0.2? Because H2SO4, in H2SO4, molarity of H2SO4 is 0.1, but it is a strong electrolyte, so double number of H plus ions are produced. That means molarity of H plus ion from H2SO4 is double, 0.2. That's why I add 0.2 into 10. So overall millimoles of H plus ion is more. So number of millimoles of H plus in excess after neutralization, 2.5 minus 0.5, that is 2.0. So number of millimoles of H plus ion is 2.0. So what is the H plus ion concentration? That is equal to number of moles of H plus divided by volume of solution in liter, or it can be defined as number of millimoles of H plus divided by volume of solution in ml. So number of millimoles of H plus ion कितने हैं 2, and volume of solution is 20. So it is 0.1, means 10 raised to power minus 1. So what is pH? pH is minus log of H plus ion, that is minus log of 10 raised to power minus 1, that is pH equal to 1. So that means C option is correct. pH of the resulting solution is 1. Understood? Any doubt in it? Okay, great. So next question is this one. Do it. Okay. So now in this question, This is the question, right? Consider three vessels containing aqueous solutions of a weak acid Ha, initial concentration C1 and degree of dissociation alpha 1 for Ha. Another weak acid Hb, initial concentration is C2 and degree of dissociation is beta 2, and their mixture, in which initial concentration of Ha C1, degree of dissociation now alpha 3, and initial concentration of Hb again C2, but degree of dissociation is beta 3. So when C1 and C2 are varied, what is the correct plot? We have Ha, so Ha give H plus aqueous, A negative aqueous. Initial concentration C1 for Hb H plus, B negative, C1, and it is 0 0. Alpha 1 is degree of dissociation when it is in uh, vessel 1. So C1 1 minus alpha 1. So it is C1 alpha 1, C1 alpha 1. Second is initial concentration C2 in vessel 2. It is C2 1 minus beta 2 because it is beta 2. So C2 beta 2, C2 beta 2. Now when they are mixed, after mixing, vessel 3, Ha plus Hb to give H plus aqueous plus A negative aqueous plus B negative aqueous. It is C1 C2, but now it is C1 1 minus alpha 3, C2 1 minus beta 3. So what is concentration of A negative? It is C1 alpha 3, and B negative, it is C2 beta 3, and H plus concentration is C1 alpha 3 plus C2 beta 3. These are three vessels. Right? Now it is written assuming alpha and beta to be small. So what is the correct plot? Right? In first case, alpha 1 C2 C1 half and alpha 1 by beta 2. Okay, so in first, let us write it as KHA, that is equal to H plus ion concentration, A negative ion concentration divided by HA concentration. So KHA is equal to C1 alpha 1 C1 alpha 1 divided by C1 1 minus alpha 1, and you know alpha and beta are very small, so it is rejected. So it becomes C1 alpha 1 square equal to KHA. That means alpha 1 is equal to KHA divided by C1 square root. Now KHB is equal to C2 beta 2 into C2 beta 2 divided by again C2 1 minus beta 2. Again beta is very less than 1. So KHB is equal to C2 beta 2 square. That implies beta 2 is equal to KHB by C2 square root. So alpha 1 by beta 2 alpha 1 by beta 2 is equal to square root of KHA upon C1 divided by square root of KHB by C2. That means KHA into C2 divided by KHB into C1 whole square. So square root of KHA by KHB, that is some constant, multiplied by C2 by C1 square root. So if we plot alpha 1 by alpha 2 versus C2 by C1 square root, alpha 1 by beta 2, C1, C2 by C1 half, C2 by C1 half, alpha 1 by beta 2. Tell me out of A and B which one is correct, because which option is correct? Is it A or B? Beta, it is Y. This is Y. Alpha 1 by beta 2 is Y. This one is constant, KHA upon KHB square root, that is slope, and this is X. So if X varies, C2 by C1 square root, if it increases, what about Y? Y also increases. So if C2 C1 square root increases, alpha 1 by beta 2 should also increase. It does not remain constant. So A option is not correct. In case of BC, when C2 by C1 square root increases, alpha 1 by beta 2 also increases linearly, because there is a linear relation. So B option is correct. Okay. Now come to alpha 3 and beta 3. So they are treated separately. When vessel 3, that is a mixture. So HA, again same relation. Concentration C1, 0, 0. It is C1 or 1 minus alpha 3 when it is mixture. C1 alpha 3, C1 alpha 3. So now KHA becomes H plus ion concentration, A negative ion concentration divided by C1 into 1 minus alpha 3. Alpha is very, very less than 1. Again C1 C1 cancel. C1 alpha 3 square equal to KHA dash. So alpha 3 becomes again square root of KHA dash by C1. And same is the case with second HB. Now instead of alpha 3 it is beta 3. So now beta 3 becomes equal to KHB dash by C2. So again alpha relation is alpha 3 beta 3. So alpha 3 by beta 3 is equal to square root of KHA dash by KHB dash into again C2 by C1 square root. Again this is Y into mx. So alpha 3 by beta 3 versus C2 by C1 half. Wait. Okay. But in the mixture, H plus ion becomes C1 alpha 3 from HA and C2 beta 3 from HB. KHA dash H plus ion A negative divided by HA, but it is in the mixture. That's why H plus ion comes from both. So it is C1 alpha 3 C2 beta 3 into C1 alpha 3 divided by C1 1 minus alpha 3. But alpha is very, very less than 1. So KHA dash is equal to C1 alpha 3 plus C2 beta 3 into alpha 3, because C1 alpha is very, very less than 1. So 1 minus alpha 3 is 1, and C1 is cancelled by C1. So in short, alpha 3 becomes equal to KH A dash divided by C1 alpha 3 plus C2 beta 3. बेटा ये समझ में आया आपको पूरा? Why I write H plus ion concentration as C1 alpha 3 plus C2 beta 3? Because in vessel 3, HA and HB both are present. So H plus is counted from both HA as well as HB in the equilibrium. In the second case, again it is C2 0 0, C2 now 1 minus beta 3. So it is C2 beta 3 from HB, but more H plus ion are there from HA. So C1 alpha 3 and B negative, it is C2 beta 3. So KHB dash, that is equal to H plus ion concentration. So H plus concentration is C2 beta 3 plus C1 alpha 3 into alpha 2 beta 3 divided by C2 1 minus beta 3. Again beta is very, very less than 1. C2 is cancelled by, sorry, C2 beta 3 C2 beta 3. So C2 is cancelled by C2. So KHB dash is equal to C2 beta 3 plus C1 alpha 3 into beta 3. So beta 3 is equal to KHB dash divided by C1 alpha 3 plus C2 beta 3. Right? So alpha 3 beta 3. So now alpha 3 by beta 3 is equal to alpha 3 is KHA dash upon this total, alpha beta 3 is KHB dash upon this total. So alpha 3 upon beta 3 is KHA dash by KHB dash, and that is some constant. So इसका मतलब क्या हुआ? Which option is correct? Out of C and D, which one is correct? Yes, C option is correct here. Reason being, it is independent of C2 and C1. Square root. So B and C options are correct. So vessel 1, vessel 2, there is HA alone In vessel 2 there is HB alone, and in vessel 3 there is a mixture. And when there is a mixture, H plus ion comes from both, from HA as well as HB. Okay, next question. Two vessels X and Y contain aqueous solutions of weak acid HA and its salt NaA. The following two equilibria, HA plus H2O to give H3O plus A negative, and A negative plus H2O, because HA is acid and A negative is its conjugate base. They exist in vessels X and Y respectively. Now at equilibrium, at a given temperature T, concentrations of HA, H3O plus and A negative in vessel X are given C1, C2 and C3 respectively, while that of A negative, HA and OH negative in vessel Y are C4, C5 and C6 respectively. So let the quantity C2, C3 into C5 into C6 divided by C1 into C4 be denoted by Q. So correct plot of natural log of Q versus 1 upon T is. Okay. So first equilibrium is HA plus H2O to give H3O plus A negative. So Ka. Okay, in this case at equilibrium concentrations are given C1, C2 and C3. This is vessel X. C1, C2, C3. So Ka H3O plus concentration, A negative concentration divided by HA concentration, C2 into C3 divided by C1. Now vessel Y, A negative plus H2O to give HA plus OH minus, concentration C4, C5 and C6. So Kb, this is dissociation constant of acid, and Kb is dissociation constant of its conjugate base. So that is equal to C5 into C6 divided by C4. What is Ka into Kb? Dissociation constant of acid multiplied by dissociation constant of a conjugate base, that is equal to Kw, means C2 into C3 divided by C1 multiplied by C5 into C6 divided by C4, that is equal to Kw, means C2 into C3 into C5 to C6 divided by C1 into C4 is equal to Kw equal to Q. C2, C3, C5, C6 divided by C1, C4, it is denoted by Q. That is the ionic product of water. That is the ionic product of water means K. And you know, any different constant or rate constant, that is related to, according to Arrhenius equation, K equal to A into e raised to power minus EA by RT. Same is the relation here. KW, some constant, any constant x multiplied by e raised to power minus delta H by RT. So in this case, Q is equal to any constant into e raised to power minus delta H by RT. So natural log of Q is equal to natural log of this constant minus delta H by RT. So if we plot natural log of Q versus 1 upon T, graph is like this. Slope is minus delta H by R. That means option D is correct. Natural of Q versus 1 upon T. वैसे भी आपको पता है, whenever temperature increases, dissociation constant increases. So natural law of Q versus 1 upon T is decreasing. 1 upon T increase matlab T is decreasing. So natural law of Q also decreases linearly. Option D is correct. Yes. A weak acid H3A has 3 consecutive dissociation constants K1, K2, K3 in water as given at room temperature. K1 is maximum, K2 and K3 are very, very less. 10 raised power minus 4, then 10 raised power minus 8 means 10 raised power 4 times less. Then it is 10 power 8 times less. A metal M forms salt Ma, which is sparingly soluble. Solubility product is only 10 raised power minus 13 water. It also forms a water soluble chloride MCl3, which dissociates into M3 plus and Cl negative ions completely in aqueous solution. So for an aqueous solution of the acid H3A of concentration C, 1 molar at room temperature, the correct statements is or are. Yes. First of all, we have H3A, so it gives H plus aqueous, H2O negative, and value of K1 is 10 raised power minus 4. H2A negative give H plus aqueous plus HA negative. Value of K2 is 1 into 10 raised power minus 8 and Ha negative, Ha2 negative. H plus A3 negative. Value of K3 is 1 into 10 raised per minus 16. Is H plus into H2A negative divided by H3A, then H plus Ha2 negative divided by H2A negative, and last is H plus A3 negative divided by Ha2 negative. So a metal M forms a salt Ma, which is sparingly soluble, and its solubility product is 10 raised to power minus 30 in water, and it also forms a water soluble chloride MCl3, which dissociates into M3 plus and Cl negative ion completely in aqueous solution. So for an aqueous solution of acid H3A, whose concentration is almost close to 1 molar, we have to find out the correct statements. Okay. First of all, tell me, out of these three, K1, K2 and K3, tell me which one will give H plus ion to the maximum extent. Out of K1, K2 and K3, which one will give concentration of H plus to the maximum extent? Yes, beta. Beta, only K1. Why is it so? Because in K1 value is only 10 raised per minus 4, but in other cases it is 10 minus 8, then 10 minus 16. That is very, very less. Okay. Only first equilibrium goes to somewhat, means it is going to give H plus ion to the maximum extent. So this is the main reaction. So concentration is C, 0, 0. Now degree of dissociation. Let us say alpha is degree of dissociation. So it is C alpha, again C alpha. So K1 is equal to H plus ion concentration, H2A negative concentration divided by H3A. So it is C alpha into C alpha divided by C into 1 minus alpha. And alpha is very less than 1. The reason being K1 value is 10 raised per minus 4. That is less than 5%. Any value less than 5%, that is, in that case, alpha is very less than 1. So 1 minus alpha is equal to 1. C cancel. So C alpha square equal to K1. So alpha is equal to K1 by C square root. So what is H plus ion concentration? C into alpha. C into under root K1 by C. So it becomes under root K1 into C. So that means from this relation, option B is correct, but there are multiple correct options. Okay. So if you look at K1, K2 and K3, value of K3, K1 is 1 into 10 raised per minus 4. K2 is 1 into 10 raised per minus 4 divided by 10 raised per 4. Means K2 is 10 per 4 times less than K1. And what about K3? 1 into 10 raised per minus 4 divided by 10 raised per 12. This 10 per 12 times means it is K1 by 10 per 4. It is K1 by 10 raised per 12. So that means K3 is far less, very less. So the acid act as a dibasic acid, because to act as a tribasic acid, value there should be means a significant value of K3, but that is very less. So the acid acts as a dibasic acid. Now H plus ion concentration in the solution is not appropriate, because K1 is far more than K2 and K3. Now option D, if we add excess of soluble salt MCl3 to this acid solution, MCl3, we have H3A. So metal M forms Ma, which is sparingly soluble. Solubility product is very less. That means when we have Ma in the solution, MCl3, sorry, which is a soluble, it dissociates completely in aqueous solution. M3 plus 3Cl negative. This one, last one, when we add all of them, it becomes H3A 3H plus A3 negative. That means overall K for this reaction is K1 into K2 into K3, means 10 raised power minus 4, 10 raised power minus 8 into 10 raised power minus 16. कितना हो गया? 10 raised power minus 28, no 38, 16 or 12, 28, 10 raised power minus 28. That means this dissociation is highly unfavorable, but it can be formed to a small extent. But as soon as this is formed, in small extent, what would happen? At the same time, we have MCl3, so M3 plus ion from the solution, because we are adding excess of the soluble MCl3 to this acid solution, so that will combine with A3 negative and form Ma. So one of the product is removed from the equilibrium, so equilibrium shifts forward, and so on. This equilibrium complete at the end, because we are adding MCl3 in excess. So as H3A concentration is C, so concentration of H plus ion becomes 3C because of the addition of excess of soluble salt MCl3. Understood? Why would it happen? If we are not adding MCl3, H plus ion concentration is close to this, K1 into C raised to power half. But because we are adding this soluble MCl3, what would happen? There are excess of M3 plus ion in the solution, and as soon as we get A3 negative ion, even to a small extent, that will combine with M3 plus, and therefore from the equilibrium A3 negative is continuously removed. So equilibrium shifts forward according to Le Chatelier's principle. Okay, and that's why concentration of H plus at the end becomes equal to 3C. So of A, B and D are correct. This reaction, see, this is in 2015 as well as पहले भी क्वेश्चन आया था, exact concentration. So same B option is correct. So this is all about ionic equilibrium. Now in a redox there are only two reactions, two questions. First one is this one. Do it. This question came in 2024. यस बेटा। Let's see, MnO4 negative to give Mn2 plus. So to balance it, it is in acidic medium, right? So MnO4 negative, it give 4H2O, 8H plus 5 electron. At the same time, I negative gives IO3 negative. So 3H2O plus 6H plus 6 electron. So it is multiplied by 5 and it is multiplied by 6. So 6 MnO4 negative, Y 5 I negative. Very good. So option A is correct. Or we can do it by oxidation number method. What is the oxidation number of Mn? It is plus 7. Oxidation number of Mn2 plus is 2. So there is a decrease of 5. Iodine minus 1, 2 plus 5. So there is an increase of 6. So it is multiplied by 5. This is multiplied by 6 to equate electron gained and lost. Second question is this one. In the following reaction, 2Na solid plus Cl2 gas to give 2NaCl, sodium change from 0 to plus 1. That means sodium is oxidized. So it acts as reducing agent. Chlorine from 0 to minus 1. It is reduced. So it acts as oxidizing agent. So sodium is oxidized, right? But it acts as reducing agent. But it is written as oxidizing agent. Sodium is reduced. That is totally wrong. Chlorine is oxidized, wrong. So this is the correct option. So Cl2 is reduced and act as oxidizing agent. So that's all. There are already 2 questions in 2022 and 2024 from the redox. Next time we will do questions from chemical kinetics. Okay. So you may leave now. Bye bye. ओके, तो ये बंद करते हैं।